When the low energy Victorian house is occupied, we will be measuring its performance. A very important part of this project is we want to find out how much energy the house actually uses when it's in use. We're very lucky in that Urban Buzz has funded this part of the project. It allows us to give us some hard evidence of how a refurbished Victorian house will actually behave when it's occupied. EDF, the utility company, have installed intelligent meters in the house. This will allow us to have a detailed readout of how much electricity and gas the house is using. As well as the utility meters, we have installed heat meters on the central heating system. This will allow us to know how much energy is specifically being used to heat the house. At the same time, we're measuring the temperature in the main rooms of the building, and we can compare this with the external weather measured by a weather station. As well as looking at how much energy is being used by the house, we're also monitoring how much energy is being produced by the renewable energy systems which we have installed. So we will be looking at how much electricity is being generated by the photovoltaic system, and also how much hot water is being produced by the solar thermal system. Before the house is occupied, we will be testing the house specifically to find out how airtight the house is. For this, we will be using a blower door test, which is also called a fan pressurization test. We will be able to identify leakage sites where cold air is coming into the building. When we do the pressurization test, we will also use an infrared camera and smoke sticks to identify leakage sites. Also, we'll be carrying out a co-heating test. This is to measure the fabric heat loss of the building. We will use electric heated fan heaters to heat the house to a constant temperature for a period of approximately 1 week. By measuring the internal temperature and the external temperature, this will allow us to calculate the actual heat loss coefficient of the house. The monitoring system has been designed to be as unobtrusive as possible, and the tenants won't really know that it's actually there. It's all automatic, and the data is collected and downloaded automatically by computer and modem. When we are measuring the performance of the house, we want to try and capture how the house performs when it is used in a normal manner by real tenants. So we're not asking the tenants to behave in any unusual way. We will be asking them to heat the house and use their house much as they would any other building. When we look at the data, we'll be able to normalise both the energy and temperatures and normalise them for how the tenants are actually using their building. So if the tenants are choosing to heat the building at a higher temperature than we think is energy efficient, we'll be able to adjust the data to reflect how the house would have performed if the tenants had chosen to heat the house to a lower temperature. We've installed relative humidity sensors behind the insulation. This is to test if we're getting interstitial condensation forming on the now colder surface of the external wall. In each room, we're also measuring the relative humidity. An important aspect of this house design is we're trying to make the house more airtight so it's energy efficient. But the risk you run is when you increase the airtightness of the house, if you don't have adequate ventilation, you may in the future have indoor air quality problems. So it's very important to measure if we're getting too much relative humidity within the room, which may lead to future condensation problems.